Hello, everybody. Welcome to the Internet of Things Automated Dashboard by myself, Kyle Koenig.
My name is Kahrhoff.
And I'm Matthew Bailey.
So our main problem that we wanted to solve was that managing IoT devices within organizations is complicated by the multitude of communication standards, leading to a reliance on vendor-specific dashboards, often leading to having many logins and different dashboards to view all the devices on a network. This decentralization hinders the creation of a unified security model and a risk assessment, making it challenging for an IoT professional to identify the vulnerabilities and implement effective security measures across the IoT ecosystem.
So our solution is one centralized dashboard that utilizes ARP to detect and display almost all IoT devices on the network. It features a modular design for easy expansion and provides important device statistics, including uptime and identifying information. The dashboard provides easy customization to add devices that are not discoverable by the ARP protocol. For example, a serial connection over USB with no networking infrastructure built in. And administrators can retrieve specific device outputs, enhancing risk assessment and network security.
So as far as the overall design process went, we focused on a proof of concept first, testing 3 types of IoT devices, one of which was a Ring camera talking through a cloud API, meaning it talks through servers elsewhere. Another one that was connected through a local area network, the Roku camera, and a custom Arduino, which only talks through a serial connection. We did this to make sure we could test over all kinds of different communication methods. So the way the program that works on kind of the back end, it'll do an ARP, it'll clear the ARP cache and request a new one. So it'll get a list of whatever the most up-to-date IP and MAC addresses are. And then we'll take all of that information and it will create a bunch of device objects to house all that information. If it finds MACs it knows, it'll update them if they've changed their IP. And if it finds new ones, it'll go ahead and make new devices for them with that IP address. From there, it runs Nmap scanning in the background and creates all of this to output files, which we'll show you shortly. And it can actually read back through those output files to get all the information. With Nmap scans, we can get port information and anything else. For the Arduino, we actually made a submodule that is a subclass of device for the Arduino specifically that lets us add more specialized functions, such as our serial PuTTY connection, to get that information, which is how we can get specific information for specific devices. They'll just need modules built out accordingly, which will be the future of this project. And after that, everything gets stored to a CSV file for use in the dashboard.
Some of the main problems and challenges we faced in the beginning was overcoming some of the communications and encryption that are built into the very common industry devices like the Ring cameras and these commercial devices actually encrypt the data. So it's pretty hard to pull anything from that device without having like the actual dashboard to do so. The second main problem was pulling data from all these different devices and standardizing it to be able to automate from any kind of device. The third main problem that we ran into was centralizing and displaying this data. We had an initial idea for the dashboard framework, and we ended up having to change directions during that to display the data correctly.
So here we have some proof of concepts. These are just some example outputs. The blue boxes on the left and the center just show proof of concept that we can actually identify new devices on the network. These 2 scans will run sequentially on my personal home network, and we can actually see my Ring camera show up once it was plugged in. On the right is an example of what that actual ARP cache is going to look like once it's printed to a file. And it's basically just a list of everything that we can then scan through and find only what we want to find.
So here is our dashboard. It reads in the data from the CSV files output by our scripts and displays the important information, as you can see there with the device name, the uptime, the IP, and then example MAC addresses. This is example data. And then it has a graph on the bottom that shows when the device was seen online, indicated by the 1. And when the device was offline during the scans, indicated by the 0.
Thank you very much and enjoy.